Hi, and welcome to the second tutorial on TNet. In this example, I'm going to create a very simple game, and I'm going to do it from scratch. So, I'm going to start by creating a new project. ctemp TNet example 2. So here I have Unity and a brand new scene with nothing in it. First thing I'm going to want to do is open the folder where I have the TNet package and import it in. If you picked it up through the asset store, just import it through the asset store. But the idea is the same. You will get this. And just hit import. So here we are. Now we have TNet with all the examples. The examples folder is not necessary in this case. So I'm just going to go ahead and delete it. So first thing we'll want to do is actually start a server. If you go and select the zip file TNet server, right click on it, show it in Explorer, and go inside, you will notice that there is an executable here. This executable is the actual server application. Now you can actually run it from within Unity if you want, but in this case I'm going to have a standalone server. The advantage of a standalone server is it'll actually be able to run it on a completely different computer. For example, like an Amazon cloud. And I'm just going to paste it here. Now that I have it here, I'm just going to run it. The first time I run it, I'm going to get this. I'm going to allow access to everything. Unfortunately, because I didn't allow access on time, I'm going to get this gateway not found note. So I'm going to hit Q and shut it down. Then I'm going to run it again. The second time I run it, it will be able to find the gateway and it will be able to open up the ports. Now, opening up of the ports is fairly important because this is what allows people connecting from the outside to actually get to your internal computer. Otherwise, they will normally be blocked by a router that you have in place, or a gateway, either or. So let's go back to Unity. Now, I don't know how you want your game to connect or when, whether you want it through a menu or upon instantiating of the game. But in this case, I'm just going to keep it simple and have it connect to the server as soon as the game is started. In order to do that, I'm going to create a new game object and I'm going to add a new component to it called TNet This is the component that will allow you to automatically join a remote server. In this case, I'm just using a local address 127.0.0.1, which always points to the computer where this application is running. If you actually have a remote server, like for example on the Amazon cloud, you would replace it with an appropriate address. The first level that I'm going to want to load, I'm just going to call it game. Channel ID, I'm just going to keep it as 1, it's fine. On disconnect level, well, I'm just going to call it disconnect. Success and failure function names. If you actually want to receive notifications of when this operation succeeded or failed, you would attach a new script here and implement the appropriate functions. But in my case, I'm just not going to worry about it because I don't really care. Now I'm going to save this scene and I'm going to call it start, because this is a starting scene. Next, I'm going to create a new scene, and inside of this scene I'm going to add say a GUI text. In the GUI text I'm going to say disconnected. This will be the disconnected scene. Predictably, file, save the scene, and call it disconnect. Now I'm going to create a new scene again. And inside of this one, I'll also create another game object, GUI text, and call it connected. This scene I'm going to save and call it game. So now there's 3 scenes. The start scene, which contains the game object that connects to the game scene, and when we disconnect, it's gonna go to the disconnect scene. Well, just to make it visible, let's add a new GUI text here and say connected, connecting rather, just to indicate that we're trying to connect. Save it. Now, if you actually go to File and Build Settings, you'll be able to add these scenes, which is something you gotta do before you're actually able to build. Otherwise, Unity will not be able to actually load these scenes. So now that this is done, let's hit Build and Run. I am just gonna call it example 2 and run it. I will allow it access, and if you notice here, it's actually saying connected. That's because it already connected as soon as you started the game. Now, if you actually go back to the server instance and wait a little bit, any day now, there we go. Timed out, disconnected. And if you actually go back here, you'll notice that you are now in a disconnected scene. Now, why did you get disconnected? Well, that's because in the build settings, you have to go to player settings, go to resolution and presentation, and you need to check this checkbox right here, run in background. This will allow the game to keep running even if when it doesn't actually have focus. So let's try this again. Build and run, replace it, and here it is. It has connected, and if I actually go back to the server now and wait, it will not disconnect. Well, in order to keep the video short, I'm just gonna assume that it works perfectly fine, which it will. Anyhow, let's move on. Well, let's go to the game scene and set it up to be an actual game. I'm gonna get rid of the GUI text, and I'm gonna create a cube. This cube will be just a plane, in my case. I'm gonna position it at the origin, and I'm gonna give it a scale of, say, 20. 120. Now, I am gonna switch to a perspective mode, and holding Alt, actually move it a bit. Something like this, for example. Game object align with view, so I can actually see the playing field. Of course, it would be helpful to add a light source as well. So I'm gonna add a directional light here. Next, I'm gonna create the actual player. In this case, it's just gonna be a capsule. It would help to actually move it up a bit so I can see it. And there it is. Say this is the player. And it kind of sucks, I know. Well, let me do some tweaks. Create a new game object. I'm going to position it at the origin. And hold on, let me get rid of that. Go to the capsule and actually lift it up a bit so that it actually sits or stands on the ground. And now I'm going to parent it to the game object that I've created. And this is the game object that I'm going to rename to be player. Next, I'm gonna re-enable the cube and lower it by 0.5 so that it actually is at the ground level. Next thing I'm gonna want to do is actually add another component to the player called autosync. Autosync is what allows you to automatically synchronize one or more properties on a game object of your choice. In this case, I'm gonna want to synchronize the transforms position, for example. Now, you don't have to use this script at all. You can actually create your own scripts and use remote function calls instead, which is something I actually advise doing. But in this case, just to keep it simple and straightforward, I'm gonna go ahead and use it. And just to be thorough, I'm gonna explain what these properties do. Saved on a server means that all the changes to this game object will be saved on the server, so when the new player joins in, they're gonna get the updated version of the whatever it is you're synchronizing. Important means it's going to be sent through TCP rather than UDP. Position updates are typically not very important and you can just uncheck this, but I'll keep it on just for now. Only owner can sync means that only whoever created this object will be sending out the updates. This is ideal for things like player avatars, because thinking of something like World of Warcraft, you don't want other players to be sending information about the player object that you are controlling, right? So just keep it on. Now, in order to keep things simple, I'm gonna navigate back to where I have the Unity package, and I'm gonna import one specific script called touch handler right here. This script will allow me to easily handle events and GUI style. If you have GUI, I recommend importing GUI instead. So in order for the events to work, I'm going to select the main camera and add that script here. Touch handler. Okay, now we are going to be able to click on things, but before we actually create a script for handling of a click, let's actually create a script that will allow us to actually find the player. So I'm going to create a new C# script and I'm going to call it game player. Inside game player, I'm just going to quickly code it. Static public game player instance. Inside the await function, I'm going to set it. Now I am going to be able to find this player. If I actually tab back to Unity and attach this script to the player object, I will be able to find it. Of course, it's better to do one other thing. If is this my object? Because I only want to set it for my player, not other players. Okay. And now to handle actual events, create a new script, call it ground, for example. Inside the script, I'm going to implement an onClick function. And inside this function, I'm going to do a player, actually game player, instance, transform, position, and I'm going to make it touch handler, world position. Let's see what happens. Let's attach the ground script to the ground and run the game. Very simple way of actually moving the player. Well, let's save the player as a prefab. And now that it's a prefab, delete it from the scene. What we should do instead is actually create a new game object. And on this game object, give it a position of where the player will start. In this case, it's just 0. And add another of the auto series of scripts called auto create. In auto create, we're going to reference the player. And the persistent checkbox is going to be off. What this means is when the player that actually created it will leave, this object will be destroyed. Now the script itself, TNAutoCreate, will simply create the object of your choice as soon as the player enters the scene. This is ideal for things like the player's avatar. So let's save the scene and go back to the menu. In the start scene, let's see, here we go, objects array. This is where you actually need to reference the player. If you don't do this, TNet will not be able to create this object for you. Save the scene and let's do a build. Build and run, example 2. Now when I actually play it, I'll be able to control it, hit it here, and I can also control it. And when one of the player leaves, the object will be automatically destroyed. Well, let's make it more interesting. Let's make the players move smoothly instead of abruptly like that. On the player, I'm gonna get rid of the TNAutoSync script and write my own custom function instead. I'll just do it inside the game player. In order to easily make use of TN's functionality, I'm gonna derive it from TN behavior. Okay. Next, I'm gonna add a vector here. I'm gonna call it target. And I'm gonna add an update function. Instead the update function, I'm simply gonna use this value. Transform position, I'm gonna make it vector 3, move towards from transform position to target position. And maximum distance delta, say I want to use 3 units per second, so 3 multiplied by time, delta time. Alright, now I need a property to set the target value. So public vector 3 target, and I'm gonna have a setter. In the setter, I'm gonna do this. TNASend, and I'm gonna give it a function name. Unset target. Target is gonna be going to all saved, and the value is failure. What this means is whenever the target is changed, there's going to be a network function called onSetTarget, which I'm about to implement. And inside here, there's a vector 3 parameter, which is this guy. And all I'm going to do inside is simply do target equals position. Now, this gives me an error, so there's one thing I forgot. If you're doing this in JavaScript, you can just do the same thing by using tnet.rfc instead of just rfc. But yeah, that's the basic idea. Instead of setting a value directly like this, what you need to do instead is call a remote network function. This way, what you're actually setting will be synchronized across the network in a single packet. There's just one other thing that we gotta change. If you go to the ground script, you'll notice that we're setting the instance transform position directly, which is not what we should be doing anymore. Instead, we should set the target to this value. So let's see what happens when we play the game now. That's a lot more interesting, right? Let's do a build. And of course, here, Neat, huh? Alright. Now, there is one bug that you might have noticed, and let me demonstrate it again. I'm gonna move this guy into the corner, then I'm gonna run the example again. And notice that the guy is actually stopped back here, but if I actually hit play now, I'll see it move from the start, even though it's not right. Now this happens is because we only synchronize the value once. If we go back to script again, as you can see, what we're actually doing is when we click on the ground, we set the target position, which is set only once. And this is the value that gets synchronized across the network. We never send the constant position anymore because we removed the sync script. And it's good, actually, because the sync script was actually sending positions something like 20 times per second if they were changing. So we can add it right now and we'll get the effect of position always updating, but it's going to result in too many packets. You got to consider that when developing network applications. So what can we do? Well, it's actually fairly straightforward. Let's add on player network player join. This function will be called when a new player joins the scene. Inside, we can do this. Now I will implement this function. And here I'm going to do that. Transform position equals that. That's it. Actually, there is one minor thing that's wrong. It's this. On target set immediate should actually be sent to the player, not to everyone, and it should definitely not be saved. Okay, that should be it. Let's give it a try. Move this guy into a corner and start this up. Yeah, he's actually in a corner. Pretty cool. So I'm gonna have say, let's try this. This guy is here. I'm gonna click in the bottom left corner and then join. Yeah, works fine. Okay. One last hint I want to give you guys. In here, when we actually are calling this function, we're sending this entire string across the network, which is fairly long. It's actually a lot more efficient to send a number instead, and you can do that with TNet. So for example here, I'm gonna give this function a number 5, for example, and this one number 6. You can use your own numbers. It's up to you. And instead of calling it by string, I'm just gonna call it like that. Actually, wait, this one's 6, and this one is 5. And if you do a build now, it should work exactly the same. Move this guy into a corner, hit play. As you can see, it's working perfectly fine. Well, I hope you guys found this tutorial to be useful. Thanks for watching, and enjoy using TNet.